Greetings, geometry students. Today we're going to be taking a look at one of the most important topics that was covered in Algebra 1, and that would be assembling all of the information we've been working on here lately and assembling equations of lines. Please copy down your title as well as the objectives. Okay, our stated objective for today is the student will discover the process and applications of slope-intercept form. Okay, so that should be a topic we are well familiar with, so hopefully we just have to kind of brush up and refresh our memories on how it works. The student will demonstrate the ability to utilize slope-intercept form of an equation while completing a class activity. And your essential question for the day, can I write the equation of a line in a graph? As always, press pause anytime you need more time to copy something down, and then press play when you're ready to move on. This is a very important concept, so if for some reason you did not get it in Algebra 1, you absolutely need to get it now. It's going to be important for what we're doing in this unit, but I guarantee you will never survive Algebra 2 if you do not learn to deal with the equation of a line. So let's get started. Okay. Any line that can be graphed has an equation that describes how to graph it. Now that's true not only for lines, but in all types of equations. Obviously, a graph something that exists in a graph cannot do what it does without an equation that tells it how to behave in the graph. The most common format for the equation of a line is slope-intercept form. Now you may be aware that there are different types of equations that do operate on lines. Okay, so you might have heard of things like point slope form or standard form or general form, depending on how your Algebra 1 teachers might have gone about some things, but we will be working exclusively with slope-intercept form. Slope-intercept form, generically speaking, is stated y equals mx plus b. M is the slope value of the line. We have already discussed this. We have seen its formula. We have talked about some of its properties, what makes lines go upward or downward, or rise or fall quickly or slowly, what makes them be horizontal or vertical. That is all depending on the slope value. B is what we call the y-intercept of the line. The y-intercept, of course, tells the line where to cross the y-axis. Okay, so a little side note here. The variables x and y are part of the equation of the line. And in 99.9% of the equations that you see, you will always have the x variable in the equation of the line, as well as the y variable in the equation of the line, which makes sense because our lines are interacting in the Cartesian coordinate plane. They need x values and they need y values in order to do what they do. Just like our coordinates have needed x's and y's, our lines need x's and y's as well. So we already know that the slope value controls the behavior of the line. Again, that tells the line whether it wants to go upward as you read it from left to right, or downward as you read it from left to right, or whether it wants to move upward or downward very quickly, or upward or downward very slowly. We also saw that the slope value can tell a line that it wants to move perfectly horizontal, and we saw that it also makes the line want to move perfectly vertical. Okay, so the slope provides the line with somewhere to go. Today's focus is we're going to be looking at the y-intercept value of the line, which is b. We're going to need that in order to complete the equations of the lines, and that is going to provide the line with somewhere to start. If a line knows where it is supposed to start and then it knows where it is supposed to go, then that is everything that the line needs to know in order to do what it does. Okay, so let's take a look at an example here. Actually, we've got several examples we're going to be looking at today. What is the equation of a line that has a slope of 2/3 and crosses the y-axis at -4. Okay, now there are two basic fundamental questions that we're going to have to answer about any line if we are preparing to try to write its equation. And those two questions that we need to know is, what is the slope, what's the behavior, and what is the y-intercept, where does it cross the y-axis. We need answers to these two questions so that we can assemble the equation y equals mx plus b. Okay, so let's take a look in this particular instance and see if we know the m and the b value, the slope and the y-intercept. Okay, well, reading back into the equation, looking for m. Remember, there's a lot of different ways that they can state m, state the slope, and in this case, they actually came out and told us slope of positive 2/3. So we do know what the m value is. And let's look for b. Did they tell us where the graph crosses the y-axis? And in this case, yes, they did. They told us the graph crosses the y-axis at -4. So they have provided us with all the information that we need in order to write the equation. So all we have to do is take the equation, write it down just like we have been with all of our other skills. Write down the formula without anything plugged into it yet, y equals mx plus b, and plug in the information that we have. Okay, we need the m value. We know it. It is 2/3, so we're going to plug it in. M is the coefficient in front of x. And then we need the b value, the y-intercept, which in this case is -4. So we have y equals 2/3 x minus 4. That is the equation of this line. Okay, let's look at another. What is the equation of a line that hits the origin and has a rate of change of -1/2? Now, there's a lot of different ways that these problems can be worded, and in some cases, some different vocabulary that can be used. So we need to make sure we know all of our synonyms. Okay, but the same two questions always take precedence. We need to know m, and we need to know b. Okay, so let's look into the problem this time and see if we know the slope. Well, they did provide us with the slope. They just did not call it slope. Remember from our discussions on slope, one of the synonyms is rate of change. So they provided a rate of change of -1/2. That is information about the slope. How about the y-intercept? Well, they didn't specifically say that it hits the y-axis, but they did say this line hits the origin. So what we need to ask ourselves now is the origin on the y-axis? And the answer is yes. The origin crosses or hits is the point where both axes join together. So our y value in this case is 0. Okay, so going into our slope-intercept form, y equals mx plus b, let's plug in our values. Our m value, we know, is -1/2. Our b value, our y-intercept, as we know, is 0. So are they going to write plus 0 onto the end of this equation, or are they just going to leave it off entirely? Well, as you know in mathematics, we do not have to write down things that do not change the value of the problem. So they're actually not going to write down that plus 0 onto the end of this equation in most cases because it does not change the value of the equation. So keep in mind, if you see a slope-intercept form or an equation that looks like slope-intercept form but might be missing that plus or minus a constant hanging onto the end of it, well, all that means is that they did not have to write it down. And if they didn't have to write it down, that means it was 0. Okay, let's look at another. What is the equation of a line that passes through points 2, 3 and 4, 5 and hits the y-axis at 1? Now, our problems have been fairly simple to this point because we've basically been provided with everything that we've needed to know. Reading into the equation, we've been able to find m and b in the problem itself. But as you can probably imagine, having everything provided for us is a little bit more like junior high, so we kind of expect in high school that they're going to withhold at least one of these pieces of information from us and make us find it ourselves. Okay, so looking into the equation, if we look for the slope value, we end up not finding it. The y-axis, b, on the other hand, they did happen to tell us it is positive 1. Okay, so we're going to need to know the slope value if we're going to write the equation. So they did not provide it for us, so the next question would be, did they give us enough information to find it for ourselves? And the answer is yes. In order to find a slope value for a line, all we need to know is any 2 points that are on the line, and we have 2, 2, 3, and 4, 5. So once again, we're going to use our skills and our strategies that we used for finding the slope of a line. We're going to take our 2 points, we're going to label them x1, y1 and x2, y2. We're going to write down our slope formula, which is m equals y2 minus y1 over x2 minus x1. Then we're going to take our slope formula and we're going to start to connect the dots here. Let's plug in the information. y2, we go up and we find that y2 is a 5, so we're going to plug it in. Minus y1, y1 is a 3, so we're going to plug it in. All of that is over x2, which is a 4, minus x1, which is a 2. We will simplify the information in the numerator and simplify the information in the denominator before trying to combine the two. So in the numerator, 5 minus 3 is 2. And in the denominator, 4 minus 2 is also 2. Just a coincidence that it happened that both of these values were the same number twice. And while slope is a fraction, and it's useful as a fraction because the numerator means something to us, that's our rise, and the denominator means something to us, that's our run. If the slope fraction can be simplified into a whole number, they will simplify it. So our slope in this case is positive 1. Now we do not have to write the denominator because a denominator of 1 does not change anything. So they're not going to write 1 over 1. They'll simply drop the denominator and make it 1. Okay, so now we have our slope value, so we can kind of go back and readdress the problem. Okay, now we know that slope is 1, so we can plug our values into our equation. Okay, so in this case, our slope value is a positive 1. So in front of the x, there's going to be a positive 1. So again, it begs the question, do we need to write down a 1 in front of an x, or is it automatically assumed to be a 1 unless it is some other value? Well, it's automatically assumed to be a 1, so we do not have to write down the 1 in front of the x. So most times they're not going to write that down. How about the b value? It is a 1, so do we need to write that down? Yeah, this time we do need to write that down because if you don't put anything there, they're going to assume it to be a 0, and it's not a 0, it's a positive 1. But there's your equation right there, y equals x plus 1. There's no coefficient in front of the x, so it is assumed to be a positive 1, which it is. Again, what is the equation of a line that passes through -3, 1, and 0, -3? Okay, well, same two questions as always for the equation of a line. We need to know the slope value, we need to know the y-intercept. Okay, well, looking back into the equation, very clearly they did not provide us with the slope value, but they did provide us with enough information to find it ourselves. So we will do that here in a moment. And the y-intercept. Did they provide us with the y-intercept this time? Yes, they did. Okay, they did not come out and call it a y-intercept, but one of these 2 points is actually on the y-axis. Point 0, -3. It is at -3 on the y-axis. So while they did not call that guy a y-intercept, this is one of the ways that they can disguise that information inside of the problem. So this one is very similar to the last problem. We have 2 points. We're going to label them x1, y1, x2, y2. We're going to pull up our slope formula, y equals the difference of the y's over the difference of the x's. and we're going to plug in our values. y2 in this case is -3 minus y1, just positive 1. All of that goes over x2, which is 0, minus x1, which is -3. So we're going to simplify in the numerator and simplify in the denominator before trying to combine the two. In the numerator, -3 minus 1 is -4. And in the denominator, 0 minus -3, remember back-to-back negatives like that is the same thing as plus, so that says 0 plus 3, which is 3. This is a fraction that does not reduce or does not turn into a whole number, so that's going to be our slope value. So it's time for us to try to plug our information into our slope-intercept form. So y equals mx plus b. In this case, we know that our slope value is -4/3 x, or -4/3, and our y-intercept is -3. So -4/3 x minus 3. That's our equation. Okay. One more example, and this is kind of the worst case scenario that we can expect. What happens if the y-intercept is not provided for us either? Okay, so here is a typical type example, and this is the skill that they are absolutely going to have you practicing if they ask you a question about writing an equation of a line. What is the equation of a line that passes through points 1, -4 and 4, -3? This time, as I've already suggested, as we ask our questions, what is the slope value? We will not get a response. And then we ask the question, what is the y-intercept value? We do not get a response there either. So it is up to us to solve for both of them. So now the question is, well, how do you begin if you don't know either one of them? Well, we're going to begin the way we have been beginning the last couple of examples. We have 2 points, and if we have 2 points, we can absolutely find the slope. So that's what we're going to do. We're going to take our 2 points, we're going to label them x1, y1, and x2, y2. We're going to write down our slope formula, which is y2 minus y1 over x2 minus x1. And we're going to plug in that information just like we have for the last couple of examples. y2 is -3, y1 is -4. x2 is 4, x1 is 1. In the numerator, -3 plus 4, remember double negative makes a positive, so that is a positive 1. And in the denominator, 4 minus 1 is 3. Okay, so our slope value is 1/3. No big deal getting that part accomplished. Okay, so we know now the equation is trying to say y equals 1/3 x, but b is still unknown, and we are not finished until we get that value found. Okay, so now the question becomes, how do you come up with a b? And here is how you do it. You have 2 points that are on the line. We are going to pick one of them, just one, either one, it does not matter which, and you are going to plug that coordinate in for x and for y. Now what that means is this. We have an equation, or part of an equation, y equals 1/3 x plus b, and we have these 2 points, x1, y1, and x2, y2, and we know that they are definitely on the line. So what we're going to do is we're going to pick a point that we like. It does not matter which one. And in this case, I'm taking the first one, and I'm going to take the point's y value, and I'm going to install it into the equation where y goes. And I'm also going to do the exact same thing for x. I'm going to take the x value from the point, and I'm going to plug it into the equation where x goes. So I'm basically using the substitution property twice here, plugging values in. Now you could have used the other point if you want. It does not matter which. You will get the same answer. Okay, but let's take a look at why we're doing this. If we take the x and the y from one of the points and we plug them in, like so, look at the equation now. You now have an equation that has only one variable in it, and that variable is b. If we only have one variable, we can solve for b, and then we will know what the value of b is. Okay, so we're going to simplify here. Over on the right side, I need to do some combining like terms. I have the 1/3 times positive 1. That's two fractions multiplying times each other. Remember, when you multiply fractions, you multiply the numerators together and the denominators together. So that's actually 1/3 times 1/1, which results in 1/3. Then the only thing left to really do is get the b by itself, which would mean we need to move the 1/3. It's a positive 1/3, so we can subtract it to the other side. And in this case, the subtraction is very simple. If you subtract 1/3 from both sides, we end up with negative 4 1/3 on the left side. Now, if we had found need to combine a couple of strange fractions, remember you have to do common denominators just like you did back in junior high. But we have a b value now, negative 4 1/3. Okay, so we have an equation before that was missing a b value. Now we know what the b value is, so we can plug in our values, and we have the completed equation of the line, y equals 1/3 x minus 4 1/3. Now, is it possible that your lines are going to be crossing your y-axes at fractional locations? Absolutely, especially if the y value, if the b value is not given to you. A lot of times your slope-intercept form will have a fractional b value. That's just the way that it is. Okay, there's only a couple of exceptions to these rules, so let's get these down real quick, and those would be horizontal lines and vertical lines. With a horizontal line, your slope value is actually 0. Okay, it is a 0 because your line is refusing to rise, but it is running. So you get a 0 in the numerator of your slope fraction. 0 as a numerator of a fraction is the value 0. So a horizontal line looks like that. Obviously it is running, but it is not rising. Okay, and on the equation of a horizontal line, basically, since your slope is 0 and slope is the number in front of x, basically that says you have 0 x's in the equation. If you have 0 x's in the equation, are they going to write any x's down? Of course not. You don't have to write down that there's no x's. You just leave them out of the problem. So your equation will always say y equals, and then you will have a number that says wherever the line crosses the y-axis. And in the case of the diagram over on the right side, the equation would be y equals, and it crosses the y-axis at negative 4. So if you ever see an equation that is missing its x values, the only way it can be missing its x values is if it did not have any, and that would be because it is a horizontal line. Now in the case of vertical lines, okay, with vertical lines, our slope fraction is undefined. Okay, and if you think about that fraction, basically, if it's vertical, that means it is rising, but it is not running. And if it refuses to run, it must be going straight up and down. That puts a 0 in the denominator of that fraction, and 0 as a denominator of a fraction is undefined. Okay, so this value, we cannot plug an undefined number into an equation and have the equation still hold true. So the equation of a vertical line is going to be different from any other type of a line. Okay, so here is an example of a vertical line. Okay. In the equation of a vertical line, since slope-intercept form does not apply, its equation actually reads x equals. And then we have a value that tells us where our line crosses the x-axis. And in the case of the graph over on the right-hand side, that equation would be x equals 3. Now, an easy way to keep these straight in your mind or to understand them is basically to think about this. All lines have an x and a y value in their equation because they cross both the x and the y axes. But a horizontal line does not cross the x-axis, so it does not need an x variable. A vertical line does not cross the y-axis, so it does not need a y variable. So if you can kind of keep that in the back of your mind, it'll tell you everything that you really need to know about horizontal and vertical lines. Okay, we're going to look at one example together when we get in class, so we'll come back to that. So at any rate, do your summary and jot down any questions that you might have. This is a very important skill, so absolutely work on this. Look back at the examples. If you did not understand them, come in and ask questions if there was something that caused you problems.